by increasing the length and width. Okay, I think this is it. Now we'll convert this to editable poly. We'll right click on this and convert to editable poly. Next, we'll select the polygons which is not selected, that is the base. Now we'll apply another UVW map, and this time it will be projected from the top view, and then we'll apply a new material to the polygon, and from diffuse bitmap we'll choose something like this, which has a seamless edge and can be tiled, which can be repeated continuously, seamlessly. So we'll choose this. So this is what we have after the unwrap. So now we'll select the polygon and convert this again into editable poly. So we'll set up the material now. We'll go to the parent, and under maps we have a diffuse color for the cliff, and now we'll add a specular color. We'll click on specular color, and on this none we'll apply a bitmap, and we have something like this created in Photoshop, so that we can apply this into our specular map. So in this way, what it will do is the areas under white and gray will have specular, and the areas under black will have no specular or zero value for the specular. So we'll use this and hit open. Again, go back to the parent, and now we'll click on bump. Use a simple normal map downloaded from the internet, and we'll use this for the bump. We'll also have a displacement working, so we'll click on displacement, and before that we'll also create a new texture, and under diffuse we'll select noise. So I'll use turbulence, and I'll select a sample type box so that I can view the texture, and I'll decrease this value to say 0.5. So now we'll apply this in displacement. We'll click on none, and from sample slots we'll choose the noise and choose instance and hit OK. So we have applied the noise on the displacement slot, and if we go to smooth highlights, we can see the specular, and we'll change the specular for the cliff. Also in the rock we'll change the specular value, and the same thing for the maps. We'll use the bump map, instance, and we'll also use the displacement, and under displacement we'll use the same noise as we have used earlier. So we'll select the diffuse color noise, map 7, and hit instanced. So under displacement we'll use a small amount, say 5, and we'll increase the bump to 50. And in the same way for the cliff, we'll go back to maps, we'll decrease the displacement to 5 and let the bump be 30. So in that way I have finished texturing the scene, and now we can start the render. And for rendering I'll be using a plugin called SIBL. So SIBL stands for Smart IBL, so it's Smart Image Based Lighting. You can go to their website at hdrlabs.com SIBL/index, and this is SIBL. So you can download the software from here. You can go to software and you can download the SIBL GUI. This is the main software, and you can also download the loader scripts for 3ds Max and Maya and other 3D applications. So these are the SIBL loader scripts, so you can download it for the various 3D applications. So after you download the SIBL GUI and install it in your computer, you need to download some of the archives that they have. You can go to archives. These are the various sets that you can download freely and use it in your lighting. So the SIBL GUI creates an image based lighting setup for your 3D application, and it creates a very realistic environment for lighting in just a matter of clicks. So you can download any of these files and use them. So we'll start up SIBL and wait for it to load, and this is HDR Labs SIBL GUI, and you can see there are some presets which are already loaded into this software. You can download this from the website and then add it here. You can add the presets by right clicking on this and click add content, and then you can select the folders where it has the SIBL presets. So you can export this to 3ds Max, Maya, Softimage and XSI. So we'll use maybe the Hollywood sign. We'll use this because it has a yellowish sky and a blue sky. We can preview the background image. So this is the background image. It has a bluish hue and also a yellowish hue. So we'll go to export. If you are not into export, you can go into the export by just clicking on it, and we'll select Hollywood sign, and from 3ds Max we'll select Mantle Ray Standard, and then we'll back to 3ds Max. We'll go to utilities, and then in Max scripts under utilities we'll go to SIBL GUI for 3ds Max. We'll execute loader script. Okay, so this is what we have. It has created an environment, a ground and a sunlight. We can change the direction of the sunlight. It also creates a skylight. So now we'll go to render setup, and from assign renderer we'll check if Mantle Ray is selected, and then we'll select camera 1, we'll lock it, and then we'll hit render, and then we'll wait for it to render. And so this is what we'll have after rendering. So this looks pretty decent, so we'll add the water surface and then we'll re-render. So we'll switch this off, save the file, we'll change the view to bounding box. We'll change all the views from wireframe to bounding box, so in that way our viewport will remain lighter when we'll switch on the fluid mesh. And for the fluid mesh, we'll set up the material system for the fluid mesh. So for the water surface, we'll assign a new material. We'll hit M to open the material editor. We'll select an empty slot, and we have two options for the ocean. You can create a customized shader for your ocean, or else you can go to standard, and under mantle ray you can either use Autodesk water, and if you select Autodesk water you can choose from swimming pool to generic sea ocean, so it will create a nice ocean. And you can also choose the color, so I'll use a tropical, and you can also use a customized color, wave height, or else you have another option, that is you can go to arc and design and you can select a template water. So for the time being I'll be using water, and will apply this on the mesh, the real flow mesh. We'll select the real flow mesh and apply this on the selection. So now if we hit render and wait for the render, okay, so this is how it looks after the render, and it serves our purpose very well. And we can change the way it looks in the compositing and make it look way better. So if you're worried about this gap over here, so it doesn't matter, because you'll be adding the foam particles and the wetland particles, so it will cover up these areas. Since this is ready, we can render out the sequence, and to render a sequence we'll go to the render setup, and in the common parameters from single we'll change this to active segment, that is from 200 to 350. We can change the output size, and I'm rendering a 720p HD resolution. We'll click on save file, and we can choose a path by clicking on this file, and you can see I have already rendered the sequence. And then you can go and hit render, and it will render out the whole sequence. So after you are done with rendering geometry, you can start rendering Krakatoa particles, and then you can go and composite it into Nuke. So to start the rendering in Krakatoa, we'll go to Krakatoa, and then we'll click on set Krakatoa as a current renderer, and we'll select yes. So after you finish rendering the geometry, we'll start rendering the particles in Krakatoa. So as you can see, I have hidden the mesh, the fluid mesh, and I have switched on the splash particle. So now to start the rendering in Krakatoa, we'll go to Krakatoa and use this set Krakatoa as a current renderer, and then we'll hit yes. So this will bring out the primary floater, and we can change every setting in Krakatoa from this box. We also need to go to preferences, and under user interface extensions we need to check on this button and then restart 3ds Max. Okay, So we don't have any light in the scene. So first of all, we need to create. For that, we'll go to create lights and we'll create a daylight system, and then we'll click and drag to create the compass, and then it creates a light. We'll switch this to manual and we'll move this light, and now we'll go to render frame window, and if we hit render, so this is what we have. So we have to work out on this to get a soft feeling of the splash. So first we'll open up the primary floater, and so this is the part where the lighting and the shading of the particles needs to be done. So by changing these values over here, we can achieve the look that you want. So first we'll change the shadow filter to the nearest, which is the best quality, and we'll also change the drop filter from bilinear to nearest, and then we'll check on this button so that we can customize the settings for render. Now if you hit render, okay, so this is what we have, nothing much. And if you go to the alpha channel, this is what you have created in the alpha channel. So we'll decrease the light density and increase the exponent. We'll have to decrease the exponent to some -4 and then re-render. And now we'll change the values in the particle density. We'll decrease this to 1 and have a density exponent of say -5. So we are not yet there, but we'll decrease this to -9 and then render again. So now we can see in the alpha channel, so I think this is a bit softer, so we'll increase this value to say -8 and then we'll hit render. Okay, so this is what we have in the alpha channel. So right now we are going to worry about only the alpha channel, and then we can use the color later. So I think this is a bit too bright, so we'll decrease this value and then hit render. So now we need to switch on motion blur, and on the particle segments, so this segment will calculate the number of passes to calculate the motion blur. So we'll need 3 passes to create a good average motion blur, so we'll use 3. And so the value over here tells Krakatoa the time duration it needs to calculate the motion blur. So 180 is half of a frame and 360 is full frame. So it will, if we hit 360, it will calculate the motion blur in one frame, and if we hit 180, it will calculate the motion blur for half a frame. So we'll hit about 270, and then if we re-render, we can see it will be rendering in 3 passes because we have particle segments 3, and it will also create the motion blur. So we can see over here the particles are getting blurred, and the fast moving particles are getting blurred. We can see some blur in this place and also in this place. So motion blur is definitely working right now. So next, if you notice, the splash particles are all over the place. So we need to mat out the geometry so that we can compose it into nuke. So for matting out the geometry, so we need to switch on, okay, we'll go to the camera view, and we need to switch on the fluid mesh and the ship and the BG. So we need to have all 3 of the geometries, and you can see I have the fluid mesh in low resolution, but for Krakatoa to calculate the mat from the realflow mesh loader, we have to switch it back to 100% of the LOD. Okay, so we have the mesh loaded. So we'll go to the select by name, and then we'll select the mesh loader, the scene group, and the ship, and then hit OK to select the three meshes. So with the three objects selected, we'll go to matte objects, expand this, and so with the three objects selected, we'll click on this create object name selection set. So what this will do is it will create a Krakatoa object set and add the three matte objects into it. So you can see it has three objects and this number of faces in it. So if this button is green, it means the matte objects are okay and we can start the render. So if this button is red, that means something is not working. So if we click on this, it will open up this list so we can see which are the objects added to the group and if they are renderable objects or not. So now if you go to the render frame window, keep a copy of this and then re-render and wait for it to complete. So okay, so we did a little bit of mistake. We forgot to switch on enable matte objects. So you have to switch on enable matte objects and then we'll hit render. So now you can see the difference that the matte objects are cancelling most of the particles which have no use, which are into the geometry, intersecting with the geometry, and it creates the matte so that we can compose this into nuke later. So we have a good result in the alpha channel, but if you switch back to the RGB channel, it doesn't work out in this channel. So now we'll have to adjust the RGB channel keeping the same value in the alpha channel. So for that, we'll select the light and under sunlight we'll change this to IES sun and we'll change the skylight into MR sky. So now if we hit render, okay, so the render is done and this is what we get. The particles are a bit too much bright and it is illuminated too much, so we need to achieve this look. So we'll select the light again and we'll decrease the intensity to say 2000 and will not use shadow. We'll switch off the shadow. So now we can see it creates a soft bluish color of the splash particles, which is pretty close to what we have in the alpha. So now we can override, we can change the color if we click on this button and we'll choose a color, say something which is, and hit OK, and then if we re-render, okay, so now we are pretty close to the alpha channel. So both my alpha channel and my RGB channel looks almost the same. We can change the exponential density and then hit render to see how it looks in the RGB channel. So I think this is a bit too soft, so we'll increase this to -7 and then hit render. No, it's illuminating too much, so we'll change this back to -8 and maybe we'll increase this to 1 and then we'll hit render. So this is what we have, and I think we'll have to decrease the intensity to 1500 and render again. So now you can see the areas over here are getting the proper illumination, but the areas over here are not getting illuminated very nicely. So we need to add another light. So we'll go to the perspective view, we'll select the light and shift drag and create an instance, hit OK. Then we'll select the head and move it on this side. Okay, now we'll select the geometry, right click on it, and under object properties we'll go to advanced lighting and we'll switch off cast shadow and receive illumination. So this will render our scene a bit faster. So we'll get back to the camera and we'll render it again. Since we have two numbers of lights in our scene, we have to decrease the intensity. We'll have 750 each and then hit render. Okay, so we need to change the color a bit. I think it's a bit more greenish, so we'll use a little bit of blue and hit OK. So now to render the sequence, we'll go to render setup and use active segment. We'll have the same output value 1280 by 720, and again save the file, and this time we'll change it to another location. We'll create a new folder and rename this to ocean underscore splash, or maybe just splash. And we'll save a PNG sequence and then we'll hit save. So now if we hit render, it will render a sequence from 200 to 350 and saving the output, and it will save the output in this path in PNG format. So we'll hit render and come back after the render is complete. So after rendering the splash particles, we'll render the foam particles and waterline particles in a single pass. So now we'll switch off splash and switch on waterline and foam. So we'll be rendering the foam and the waterline together with all the settings the same. We can hit render, but before doing that we'll have to change this back to single and click on the save file button to uncheck the save file, and in camera 1 we'll hit render. So there we have it. The foam particles looks pretty decent with the same settings. We can change the settings if you want, so we can experiment a bit by changing these settings. Okay, so maybe we'll increase the motion blur a bit, so we'll increase the segments to 4 and motion blur shutter to 400 and then hit render. So after the render, this is what we have for the foam and the wetline particle. So now we'll render out the sequence for foam particles. So we'll set this to active segment, save file, and under files we'll choose another path or make a new folder and change the name from splash to foam and save, and then we can hit render. So after we render out the foam particle sequence, so we have finished rendering the foam particle sequence and the splash particle sequence in Krakatoa. So we have to render one more sequence, and which will give the color and the illumination value for the water surface rendered in 3ds Max. So we'll open realflow, and from here we'll open up the file we have last created. So after we open our project, we'll delete everything except the emitters. Yes, we'll hit delete. We'll delete everything except the emitters and the domain. So we'll change the visibility to yes. So we have the domain loaded up. So we have only the domain and the emitters in the scene. We'll save this file as a different name. We can change the file name. We'll go to the export central. If we hit F12, it will open up the export central. We'll export the grid fluid emitter 03 and 04 and expand it, and we'll export the Krakatoa particle format, that is the PRT format, for both these emitters, and then hit done. It will be saved in this directory, that is the scene directory inside particles, and it will use the name convention as grid fluid emitter 04 and grid fluid emitter 03. So we'll hit done, go to frame 200, and then we can hit simulate, and the simulation will be very fast since it will only simulate the particles, and it will use all the data from the domain which is already in cache mode. So if we hit yes, simulate, so we can see it simulates a lot faster. So after the simulation is done, we'll go back to 3ds Max. So after the simulation is done, we'll come back to 3ds Max, and we'll go to manage layers. We'll switch off everything except the ship and the BG. Then we'll go to Krakatoa, create a new PRT loader, and we'll load the sequences that we have just seen. So after loading the two emitters in the PRT loader, we'll go to the modify list and apply a Krakatoa channels modifier, which is also known as KCM modifier. Next we'll click on auto update and open up the magma flow editor. So we'll use the Krakatoa magma flow editor to color the particles according to the velocity of the particles. So the particles which have lower speed, lower velocity will be a darker color, and the particles having higher speed or higher velocity will have a lighter color. So in this way we'll have a variation of colors similar to what we have in realflow. So we'll select this in channel, the input channel, and from the channel name we'll select the velocity. We'll type V and we'll use velocity. So next we'll click on this input and create a float integer, and from arithmetic we'll create a multiply. So we'll select this link and hit delete. We'll double click on this to expand, and we'll connect the velocity float to the multiply and integer float to the multiply. So next we'll go to input and create two numbers of vector input. So it will define the two colors, the two extreme colors for the high velocity and the low velocity particles. So we'll go to one. So we'll select the first one and change the as color to black, and the second one will have the as color as white. Then we'll go to vector and create a magnitude vector, and then we'll connect the multiply to the magnitude vector. Now we'll use a blend from functions. We'll use a blend and connect the two vectors in input 1 and input 2, and in the input blend ratio we'll use the magnitude, and then we'll output the blend to the out color, and then we'll hit update. And now we can close this magma flow editor, open up Krakatoa, and with the same values as before we'll hit render, and we'll get something which is like this. So now we'll render out the sequence in the same way we have done before, and then we can composite the different passes in Nuke. Hello and welcome to my last part of this tutorial, and in this part we are going to use Nuke to compose the different render passes that we have rendered in the previous tutorial and give the final output. Okay, so I have Nuke opened up, and we are going to first import the different render passes. We're going to hit R on a keyboard, which is the keyboard shortcut for read node, and we are going to browse the render sequences. We have 4 passes to compose with, so we'll start by importing the scene. We'll check on the sequence button and select the sequence and hit open. In the same way we're gonna import the different passes. So we have our 4 render passes. If you select the first pass and hit 1 on a keyboard, we can view it on a monitor. So we would like to brighten up the whole scene, and so we'll drop a color correction by hitting C, and it adds a color correction node to the sequence, the read sequence. Okay, so we'll adjust the color correction. Okay, I think that should do it. We'll decrease the saturation a bit more. Okay, now we are gonna add a glow. We'll hit tab and type glow. We'll select glow and hit enter. We'll connect the node to the color correction, select glow and press 1. So we are going to change the settings. I'm going to change the tint first and select orangish tone. Okay, now I'll increase the brightness and will decrease the size. So this is our foam pass. We'll use a color correction to brighten the whole foam and desaturate the bright areas. So we'll use a color correction by hitting C. We'll drop a color correction node and connect it to the read node, and we'll select color correction, hit 1, and then we'll go on changing the values. We'll decrease the saturation to 0 and it will kill off all the colors. We'll use a little bit of blur to blur out the particles. We'll select the color node and hit B to drop a blur node and use a small amount of blur, say 1.2 maybe. Okay, and then we'll use a glow. Hit tab and we have already selected glow, hit enter. First we'll decrease the size and the brightness. We'll decrease the brightness a bit, and tolerance, will increase the tolerance to say 0.05, and we'll change the tint to a orange color. So we'll drop a merge node by hitting M, connect A to the glow of the foam and connect B to the scene. Select the merge, and if we hit 1 we'll have this, and under operation I'll select plus. Okay, so I might want to readjust the color correction, brighten it up. Now I'll add the splash particles. We'll drop a color correction node, hit C, and we'll brighten it up a bit. We'll copy this glow, Ctrl C and Ctrl V, and connect it to the color correction. Hit 1. Okay, maybe we'll decrease the yellow tone and we'll drop a merge node, connect A to the splash, connect B to the foam. We would want to reverse this, so we'll select it and hit Shift X. We have our splash particle. We'll change the color correction settings and we'll decrease the glow, the tint for the glow. Okay, so now we'll use the ocean pass to use the luminance map. So use the luminance value from this image and we can add it over the final image. So for that we'll first use a blur to blur out the particles. We'll select this and hit B to drop a blur node, and we'll increase the size. Okay, so 5. So now we'll add a blur, so we'll add a merge node. We'll hit M to drop a merge, connect A to blur and drag it and place it over the connector to insert it. So in the merge node we'll change the operation to screen, so we can see that it has already created some difference. It has brightened up the areas using the color values, the luminance values from this layer. So now we'll decrease the mix Now we'll change the hue of the color, so we'll use a hue shift and hit enter, and we'll change the hue rotation to make it to give this a bluish tone, so we can see the difference. Okay, so this is it. Now we can render out the sequence. Our final output is ready. So now we'll use a write node, connect this to the last node and select a path to save it, and we'll give it a name output.mov. We're gonna render an MOV sequence, and we'll use Sorensen tree, and then we'll hit render to start the render, and it will ask for the frame range. We'll say 200 to 350, which is our sequence. Okay, we'll hit OK, and it will start rendering. So thank you for watching this tutorial. I hope you learned a lot from this tutorial, and you can drop by my blog site www.skaialam@blogspot.com, and you can come and visit my works. You can subscribe to my YouTube link at skaialam. That's my YouTube subscriber name. So thank you and have a happy simulating time.
If you guys like this video, go ahead and hit subscribe for more tutorials.